Welcome and thank you for joining us today for Next Generation Wide Area Networking. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speaker is Seamus McGillicuddy, Senior Analyst at Enterprise Management Associates. Seamus has more than 10 years of experience in the IT industry, primarily as a journalist covering the network infrastructure market. Prior to joining EMA, Seamus was the news director for Tech Target's networking publications. And before I hand things over to Seamus, I wanted today's audience to know that Seamus will be dedicating the last few moments of his presentation to answering your questions. You can log those anytime using the Q&A functionality located in the right-hand column of your screen. Also, today's event is being recorded, and you will receive a follow-up email from EMA tomorrow. They'll include the on-demand playback as well as some additional resources. So be on the lookout for that email. And now I'd like to go ahead and turn things over to our featured speaker, Seamus McGillicuddy. Seamus?
Thank you, Raleigh, and thank you everyone for joining me for today's webinar, Next Generation Wide Area Networks. This is a webinar that will highlight some of the findings from a research paper that I published last week on the subject of Next Generation Wide Area Networking. So before I go any further, I'd just like to acknowledge and thank the 7 sponsors that made this research possible, including Cisco, CloudGenix, Comcast Business, InfoVista, LiveAction, Riverbed, and Viptela. All of these companies do a significant amount of business in the world of wide area networking, so it's no surprise to see them all involved in sponsoring this research, so thank you very much. So as for the agenda, I will be starting out with a quick overview of the research participants, the people that we surveyed for this research, give you a sense of who they are and where they are. Then I will briefly look at the wide area networks that are managed and operated by these research participants, the WAN snapshot, if you will. Then we'll look at some connectivity trends, specifically the rise of the Internet as a form of primary network connectivity for remote sites, and also the rising influence or the rising importance of wireless connectivity. Then we will look at how cloud services like SaaS and infrastructure as a service are influencing the wide area network in these organizations. And finally, look at a couple of new technologies and examining enterprise activity and interest in things such as software-defined wide area networking and network functions virtualization, specifically in remote sites. So, the research participants, we surveyed 200 IT professionals who are involved in the planning, implementation, and or operation of a wide area network. 53% of them were IT staff level employees and 47% of them were in IT management roles. The IT managers tended to be involved in more aspects of the WAN lifecycle, from planning to procurement to operations, than IT staff who tend to be specialized in a couple of areas. 74% of the research pool was located in North America and 26% were located in Europe. So we have sort of a cross-Atlantic point of view on the wide area network in this research. And these are the vertical industries that were most prominent in the research sample. These are randomly emerged. We were not targeting specific verticals, but these are the ones that emerged. Finance and banking and software were the 2 most prominent. Then IT professional services, healthcare, medical, pharmaceutical, and finally service providers of a variety of kinds, application service providers, internet service providers, managed service providers, network service providers. Snapshots of these wide area networks. We specifically targeted enterprises that had enough of a distribution of sites to consider to be what we would consider a significant WAN infrastructure footprint, I guess would be the best way to describe it. Any site, any enterprise that reported having 10 or fewer sites was discarded from the survey, as were any enterprise who reported having fewer than 250 global employees. We were targeting enterprise-level organizations and organizations with 11 or more sites. And here you see the smallest cohort were those that had 11 to 20 sites, 27% of them. Most of the sample was between 21 and 60 remote sites, or 61 or more, including a small group of 7% that had more than 200 sites connected to the wide area network. And here you see the most common types of remote sites that they reported as having connected to their WAN. Branch offices, the typical location that has people working at desks, was the one that was present in a majority of sites, 56%. Then logistics remote sites, that's distribution centers and warehouses. External sites, that's partner locations, customer locations, vendor locations that are not owned by the enterprise but are connected to the wide area network in some way. Research and development was also prominent, and then industrial sites like factories or oil and gas installations, things like that. We also asked this follow-up question where we asked them to identify the 2 sites that are most important and impactful on the wide area network. And branch offices and research and development sites were statistically tied for first place there, just a percentage point or 2 separating them. We asked whether or not they were growing, or we asked whether or not the number of remote sites that were connected to their wide area network were growing, and pretty much all of them were reporting growth. 82% were increasing the number of sites connected to the WAN, including 1 in 4 who are seeing a growth rate of 25% or more annually. Only 2% were actually reducing the number of sites connected to their WAN. We also asked them how many network connections they have per site on average, and you see the plurality of respondents reported having 2 managed services connections or private connections, like a T1 line, MPLS, carrier Ethernet per site. There's a little more internet connectivity per site. 36% saying they had 2 connections per site, and then another 38% saying they have 3 connections per site. Then we asked whether or not they're increasing the number of network connections they have at each site over the next 12 months. And you see a significant minority of them are increasing both internet connectivity and managed WAN connections or private connections. There seems to be a little more growth around the internet, or at least or at least the managed connectivity is more static than internet connectivity. Which leads us to connectivity trends. We asked those enterprises that said they were growing the number of internet connections they have at their remote sites, whether those internet connections, or whether they were planning to use those internet connections to replace any managed connectivity, any private connections like MPLS. And 74% of them said that they were planning to implement internet connectivity as a primary form of network connection at least some of their remote sites. That switchover was happening at a lower rate in Europe at 62%, and North Americans were reporting it at 78%. We also asked them to roughly estimate how many of their remote sites will have internet as a primary network connection as a result of this changeover. And the mean response was 45% of remote sites, so slightly less than half of all remote sites going over to the internet as a primary form of network connections. Even higher, at 59% of remote sites, for those organizations that told us they're spending 20% or more of their IT budget on the WAN. So those who have a lot more budget devoted to the wide area network are more likely to switch over to the internet, which implies maybe cost is a major issue, but let's look at drivers to get the real answer. You see cost is actually kind of middle of the pack there. This is blue is IT managers, green is IT staff, and cost reduction just it's sort of a secondary driver. The top 2 drivers here are connectivity to cloud services like SaaS or infrastructure as a service, and then more secure was actually number 1, even more so for IT staff. Now that's surprising because the internet is not considered it's more secure than something like MPLS. So it's perplexing, but there's probably a number of reasons why they're selecting more security or more secure as a driver. I think one of those is just taking a more a better approach to managing risk. When they move to the internet, it prompts them to invest more in security, whether it is more encryption of data that's going over the internet, installing more network and security services at remote sites. And also, it's sort of probably eliminates some of the complacency that organizations might have about security when they're using private network connections, which, as anyone knows, even a private network operated by a Tier 1 provider is not 100% secure. So if you're relying on the fact that you're using a private network to give you default security, you're kind of fooling yourself, because if that network is compromised and you do not have good security practices, even on a private network, you are putting yourself at risk. So I view this as enterprises using the transition to internet as a way to prompt better security hygiene, but I think they're probably interpreting the term more secure more broadly in terms of like a business continuity idea as well, where when they're using the internet, they have a lot more flexibility, a lot more budget available to them, and they're able to build more sort of like high availability architectures as a result of using the internet. So this is going to prompt more research from us and follow-up studies to really kind of dig into what they meant by that response, but that's what my take here. We also see other drivers emerging as secondary ones, such as higher bandwidth and superior performance. Higher bandwidth is obvious. I mean, the cost per bit for internet is much lower, so you have better higher bandwidth options. Also, a lot of private network connections just are limited in the available bandwidth they have. Then you see service agility and faster provisioning, sort of down near the bottom of the list, but more prominent for IT managers. It's easier to provision an internet connection than it is for a private network connection. And at the very bottom of the list, but it's still at the bottom, but not insignificant. Basically, 1 in 5 enterprises are saying their preferred network provider no longer offers managed WAN connections like MPLS or T1 lines, what have you, in certain geographies. So what you're seeing there is enterprises, they're basically being forced to use the internet. They have certain remote sites that just don't have those private network connections available to them anymore. Looking at when you move to the internet, an obvious question is how do you adjust service assurance, monitoring, and troubleshooting for that? So we asked these respondents to tell us what tools they considered most valuable for monitoring and troubleshooting internet connectivity. And you see at the top of the list, network flow monitoring is number one. It's highly favored by IT managers more than IT staff, although IT staff still listed it as their number 2 most valuable tool. Remote global services for synthetic transaction analysis across geographies. So those are sort of cloud-based services or hosted services that sort of track internet performance across different geographies and give you, correlate it with what your application experience is like. That's number 2. That's also more favored by IT management than IT staff. Number 3, and also number 1 for IT staff, but number 2 overall when you look at the analysis is log analysis, which gives you access to machine data, really useful for troubleshooting. Packet monitoring is favored by IT managers more than IT staff. I would argue that's probably one of the least valuable tools based on how IT staff is ranking it. IT staff is also really highly prizing observed endpoint transaction performance, including on mobile devices. So it's end user experience monitoring. It's number 3 for IT staff, and then when you look at it from the perspective of IT budget growth, we found that organizations that reported having a flat or negative IT budget growth this year, they placed very little value on network flow monitoring, like net flow monitoring, IP fix monitoring, and also very little value on endpoint transaction performance, which were both highly valued by organizations that had growing IT budgets. So that tells me that they're trying to get by with the tools that they have. Their top picks: log analysis, packet monitoring, and route analytics. I think that they need to reevaluate their priorities if they're transitioning to more internet connectivity in their WAN. they really need to look at, especially investing in a network flow monitoring tool if they're going to be doing a lot of internet connectivity in their WAN. Meanwhile, wireless networking is becoming pervasive in the wide area network. 96% of enterprises told us they had some form of wireless networking as a primary WAN connection in some of their sites. We didn't ask them to tell us how many of their sites were using wireless, but 82% of them said they're using 4G and LTE in some of their sites as a primary network connection. 50% said carrier Wi-Fi or municipal Wi-Fi was a primary connection, and then a minority of them were using 3G and satellite. Europeans were more likely to be using 3G, Wi-Fi, and satellite. And then if you looked at it from the perspective of budget growth, those with flat or negative IT budget growth were less likely to use 4G LTE, which is no surprise. It's a premium form of network connectivity. But this shows that wireless WAN has really come into its own, especially the 4G. The top drivers for wireless WAN use, IT staff, top three were higher bandwidth, faster, simpler provisioning, and improved security. IT management ranked improved security number 1 instead of number 3, and then superior performance and then higher bandwidth, sort of a flipping there of security and the bandwidth. And then IT managers were more focused on lowering cost than staff. The faster and simpler provisioning is fairly self-evident. I talked to an enterprise network engineer recently who has a rapidly growing network that adds remote sites very quickly, and he said he sends out 4G LTE routers to sites that launch quickly so they can have instant network connectivity, and then replaces them later with a wired connection once he's able to get it provisioned, if wired connections are available. Depends on the geography. But so you see that as like a temporary issue. But I think the higher bandwidth, the improved security, the superior performances, and the lowering of costs as drivers indicate that temporary is not the biggest use case for wireless. That it may be a temporary solution for certain use cases, but it's clearly a situation where many enterprises have remote sites in locations where wireless is simply the best solution. It offers the best bandwidth in the location or the best performance in whatever location than maybe a dial-up connection in a very rural area. Also, when you look at improved security, I think that's driven by the prevalence of 4G and LTE, and given that LTE has several layers of integrated security in its architecture, including default encryption to the edge, really sort of reinforces that driver is legitimate. So let's turn our focus to the WAN and external cloud services. We asked a couple of architectural questions of these enterprises. First, we asked them how they connect their overall WAN to external cloud services like SaaS or infrastructure as a service. 35% said they're using a direct managed services WAN connection like Microsoft Azure ExpressRoute. And 34% said they prefer a managed WAN connectivity through a third-party peering service like an IP exchange. So these are preferences. And then 21% said they had a preference of using direct internet VPN like Amazon Web Services Direct Connect. Then we asked them what kind of architectural choices they're making for connecting their remote sites to cloud services. Are they connecting remote sites directly to a cloud or an external cloud, or are they routing that traffic through a data center or something like that for security and so forth? Basically, 55% said they're allowing direct connectivity from remote sites to the cloud. 40% saying they're using a VPN, and 15% saying they're using unsecured direct internet connectivity. Those who are using secure direct connectivity were higher, 47% among organizations that reported having 61 or more remote sites. So the more distributed they are, the more likely they are to move away from that sort of hub and spoke model for cloud access. And then a quarter of enterprises said they're routing cloud traffic through a data center. That percentage is even lower for those highly distributed organizations. And then 18% said they're routing through a regional hub. we ask them to identify what kind of challenges they face when they want to or are trying to or considering connecting remote sites directly to the cloud. And you see some variation based on the number of remote sites they have. I will first point out that the 4 bottom responses here, core network services are centralized, security architecture is centralized, security risk or risk aversion by security operations team, and then all internet connectivity is centralized. Those 4 were all kind of in a 4-way tie for the biggest challenge. And then the cultural and political issues, whether they're coming from within the IT organization or across the wall to the business organization, those are secondary. But when you look at it from the perspective of how many remote sites an organization has or how big the WAN is, in other words, there's the significant variation. Those really small networks that have just 11 to 20 remote sites, they're really impeded by risk aversion from the security operations team for some reason. And then you see those moderately distributed organizations that have between 21 and 60 sites. They're dealing with a centralized architectural problem, specifically around security architecture and core network services like DNS. And then the organizations that are very distributed, 61 or more sites, they're dealing with roughly a large group of issues, kind of a broad set of issues, I guess, although internet connectivity centralization is a big one. They're the ones that are most likely to be dealing with political and cultural issues within IT for some reason, but they're also dealing with a lot of problems associated with centralized architecture and just risk aversion from security operations. So those are the chief impediments to that direct cloud connectivity. We also asked some questions around how cloud adoption or the migration of applications to the cloud affects the network team. First, we asked them what kind of technologies and other techniques and initiatives they're adopting from a networking perspective to address this migration. You see the majority of them are doing 2 things. They're adopting cloud-specific network monitoring and troubleshooting tools. So basically they have identified that their existing tooling for monitoring and troubleshooting networks and networked application performance for traditional internal on-premises infrastructure is not suited for the cloud, so they're adopting new tools. And then cloud-specific network optimization technologies is also a big target for them. And then roughly more than a third are adopting cloud-specific network capacity planning tools. 47% of organizations who devote 20% or more of their IT budget on the WAN are clearly more likely to be using those cloud-specific network capacity planning tools. And then cloud technology training and certifications is the target for a little more than a third of them as well. And that sort of harkens back to research that I did back in December where we surveyed early adopters of software-defined networking technologies, including data centers, SDN, but also software-defined WAN. And we asked those organizations what kinds of skills and training that their networking team is pursuing in order to fully support software-defined networking. And the number 1 skill that they were targeting was around cloud technologies. So they were training themselves up on OpenStack and have Amazon Web Services and things like that. So this kind of continues that finding where we're looking at cloud training and certifications and things like that being very important for the network organizations as they're transforming their architectures. And here we also asked the networking team whether they are collaborating more with any other domains within IT as a result of applications migrating to the cloud. And you see IT service management, 60% of them said they're collaborating more with IT service management. It's more prominent here, as you see, in finance and software companies. So that tells me that network infrastructure teams, when applications migrate to the cloud, they're really becoming more conscious of and getting more involved in best practices initiatives as a result of this migration to better serve the business as these applications migrate out there to the cloud. They've identified ITSM as a big issue for them. And then the minority of them, these are the 2 secondary collaboration targets. The application management team, obviously infrastructure as a service, they're collaborating more with the apps team. And then security, obviously, move things in the cloud, security becomes a big issue, so they're collaborating more with the security team. And finally, we look at some new technology initiatives here. So first, there's software-defined WAN. So we asked enterprises to identify what stage of activity they're in with software-defined WAN. 30% said they're fully deployed, and 43% of organizations who devote 20% or more of their IT budget to the WAN said they're fully deployed. 40% said they're rolling out SD-WAN right now. 18% plan to deploy in 12 months. Only 6% said they had no plans. That number seems high. A lot of people think it's high. I think it's slightly high, but I will argue that it's a legitimate number. First of all, I did in a separate research project I did 3 months ago on various trends that are impacting networks and network management, such as hybrid cloud activity in the enterprise, Internet of Things initiatives, a few other things, network management, outsourcing and stuff. I checked in on adoption rates on software-defined WAN in that study, and that separate research sample reported that 31% had completed a production deployment, so exactly the same number. We also excluded all organizations that had fewer than 11 sites on their WAN, so this is biased towards organizations that have larger networks, which means more complexity, more cost, and those organizations are more inclined to adopt software-defined WAN for obvious reasons. And we also want to keep in mind that these are enterprises and not smaller companies, 250 global employees or fewer. Those organizations were excluded from the survey. And I've also read 2 separate surveys by third parties that have actually reported similar or higher adoption rates. One of my clients recently did a survey that found close to 40% said they adopted software-defined WAN. That was a survey from a few months ago, and then I read another market research firm's survey results a couple weeks ago that claimed to have found a 28% adoption rate. So software-defined WAN, his adoption is here. Now, the other question that I think this raises is, what is software-defined WAN? And I think a lot of vendors in the market who were marketing certain types of WAN solutions before the term software-defined WAN was a gleam in someone's eye, have pivoted towards the software-defined WAN market with those solutions. They've maybe retooled those solutions, or at least are remarketing them as software-defined WAN solutions. So you're probably seeing a lot of enterprises who are being told they're doing software-defined WAN when a few years ago, whatever they're doing was called something else. So there's probably a little bit of confusion in the market as well that I will acknowledge that might be driving up these numbers some. But whatever the case, these organizations have identified software-defined WAN as something they're doing, they want to do, and they have specific goals and drivers in mind. As you see here, the top business drivers for that adoption are improved application performance, enablement of direct cloud access from remote sites, and improved network security. Those are all things that software-defined WAN vendors market to, especially the first 2 and many, the third one. 38% of IT staff identified rapid, flexible delivery of network connectivity as a driver as well. And then 40% of IT managers said that software-defined WAN was simply the best option for network refresh, which is very concerning to me. Those are individuals that are being sold a bill of goods by certain vendors without having a business case or a business problem in mind for why they would be adopting this technology. So I'd warn those organizations to really think about the business drivers that they have, or the technology drivers or technology problems they're struggling with that software-defined WAN can solve, rather than just buying a shiny thing. They really should be identifying a problem to solve. Obviously, I think everyone listening would agree. So thinking about the shape of SD-WAN products, we asked these adopters how they were handling 2 phases of the life cycle of software-defined WAN, planning and engineering, and monitoring and troubleshooting. We asked them, how what they were doing in terms of addressing those aspects of projects, using existing tools, buying new tools, working with their software-defined WAN vendor more closely, working with the VAR, working with the network service provider that provides WAN connectivity. The largest cohort, the largest plurality of respondents said that they're using tools and services from their software-defined WAN vendor to address both planning and engineering tasks and troubleshooting, monitoring and troubleshooting of software-defined WAN infrastructure. So that's probably the mainstream approach to implementing and operating a software-defined WAN. Here you see statistics that show that a significant minority are leaning heavily on and working closely with their network service provider. 32% said they're leveraging software-defined WAN planning and engineering tools and services from their network service providers. That's more common in Europe than North America. And then 28% said they're outsourcing monitoring and troubleshooting to their network service provider, also more common in Europe. So I think what you're seeing here is there's a certain number of the mainstream approach is to go through traditional enterprise infrastructure, IT infrastructure channels, working with VARs, working with vendors to get something done. But then there's this third of the market, roughly less than a third of the market, who have identified that they're going to acquire, consume, operate software-defined WAN technology like they do most WAN services by leaning on outsourcing to partnering with their network service providers. And I think you see that in the market. A lot of software-defined WAN vendors are partnering with and going to market with Tier 1 providers and Tier 2 providers, while also continuing to build out channels to the enterprise like your traditional IT infrastructure vendor. Features and aspects of software-defined WAN that deliver the most value, split by IT manager and IT staff. You see IT management really places value on getting network functions and services out of specialized hardware. 44% value cloud-based network and security services delivered via software-defined WAN solution, and 37% like virtualized network and security services. So those are virtual network functions, on-premises device, maybe a server or a white label, white box device. And then their number 3 priority is improved network and application visibility. IT staff, they're also very interested in virtual network functions and those local appliances, and then they tend to place greater value on hybrid connectivity, whether it's active or static hybrid WAN connectivity, like load balancing traffic across multiple links, or dynamic hybrid WAN connectivity, where there's traffic engineering across multiple links based on network conditions and so forth. So they're more involved in the technical merits of infrastructure, while the IT managers seem to be focused more on sort of like the way that these solutions are consumed. And also application-based or business policy-based network management and control is something that IT staff value greatly over their counterparts in IT management levels. All right, so one last thing here, network functions virtualization. That's a topic that's very hot in the telecommunications service provider space. As many of you on the line probably know, it involves the implementation of an architecture that abstracts network functions and services traditionally delivered in specialized hardware appliances, whether it's like a router at the edge of a network or evolved packet core in an LTE network, and deploying those as virtual network functions, either running in a service provider cloud or a virtual customer premises equipment deployment in a remote site or something like that. That's a very short definition of NFV. Could go on much longer, talk about all the aspects of it, but I think it's pretty clear by now that enterprises have identified NFV as something that they can do, and it's not necessarily the same thing, but in some ways it is. They've started things like microservices in the data center. They've identified the need to have really lightweight load balancers and firewalls and highly virtualized private cloud infrastructure. But then in the remote sites, like we're looking at here, they've identified the need to have options on how they consume network functions and services in a branch office or what have you. So here we asked them to identify their preferred consumption model for 7 network functions and services. The green bar is NFV. You see the 2 big ones are WAN optimization and VPN at the bottom. Also pretty much interested in everything, actually, but network address translation, wireless LAN control, also big. So that's a virtual appliance or a virtual machine instance deployed on a server, white box appliance maybe, or a router that has a server module in it, like you see from Cisco ISRs these days, a server blade in it. So that might be driving up the interest there. Those people who are doing it through something like a traditional router with a server blade on it, but clearly they're open to NFV in the branch for a variety of things. Cloud-based delivery of these services are also of interest to a significant minority, especially as you see at the top voice services, 30% of them are interested in that. And network security is number 2 in terms of interest at 28%. That's invokes the idea of something like Zscaler, which is more frequently being integrated with a lot of software-defined WAN solutions. And then those who are sticking by the guns, the dark blue there, a lot of you see routing and network security are the ones where they're most tied to the traditional specialized appliance, but still a lot of them are willing to try different consumption models. So in conclusion, WANs are growing. Enterprises are adding remote sites. Almost all of them are. They're adding more network connections at each site. The internet is replacing MPLS and other private WAN connections in many enterprises as a primary form of connecting to the network. And also, wireless WAN is becoming very prevalent, at least some remote sites, especially 4G and LTE. The majority of organizations allow remote sites to access the cloud directly now, but security remains a concern for them, whether it's centralized security architecture or just risk aversion by security operations. And also the cloud, migration of applications to the cloud is prompting a lot of organizations to collaborate with IT services management. Software-defined WAN adoption, as we just exhaustively discussed, or I'd said discussed, adoption is heating up. Application performance is the top driver for that adoption. And enterprises are also interested in NFV, particularly for VPN and WAN optimization. So thank you very much. I appreciate the time, and now I'd be happy to take any questions. Just fire away.
Great. Thank you, Seamus. We have received quite a few questions. If we are unable to get to your question today, I will be sure to send it on to Seamus. The first question, Seamus, is, has there been any indication for when Internet would replace and displace MPLS or other managed WAN connection?
The indication here is that it's replacing. I think enterprises have identified a lot of a strategy based on the fact that they're replacing, on average, about 45% of their remote sites are replacing MPLS and other private connections with the Internet. I think that's a good indication that enterprises have identified those remote sites where it's strategically viable. I really think it depends on the enterprise and what kind of applications they are consuming and distributing over the WAN. If you look at the full report that we published last week, there's additional data in there about what preferences organizations have for forwarding traffic, whether they prefer to forward traffic. Basically, we asked across about a dozen different general classes of applications, what's your preferred method for forwarding this traffic? Private connections like MPLS, internet connectivity, or do you just have a policy of using the best available connection? And you see that certain classes of applications, they just prefer private WAN connectivity, like big data. So if you're doing a lot of big data, they really want to protect that data in terms of securing it, and also just guaranteeing the performance of the network when they're bursting all this traffic over a wide area connection. They really prefer to forward that over private network connectivity. And also storage and backup remains a sticking point. They really storage backup and recovery, they really want to have a private network connection for that. But the growth of web applications in the enterprise that's been going on for years now, I think is really sort of pushing them towards being comfortable with the internet. Basically, any application that's running over that's basically an HTTPS application, so a secure web app that's encrypted. They're going to send that over internet before anything else. There's a clear preference to forward that over the internet. So if you're an enterprise that does a lot of encrypted web applications, you're probably going to be more comfortable with the internet as a primary network connection. So that's probably going to influence things in terms of, like, if you're identifying certain remote sites in your enterprise that are doing certain types of applications. That's okay. So all these sales offices are doing encrypted web applications. So those we can just let's get rid of the MPLS connections and just push internet as the primary network connection there. But then here are the sites that are collecting, processing, storing, backing up a lot of big data projects. We got to keep the MPLS connections there. Same thing with storage and backup, recovery, things like that. So I think it's going to be really going to depend on the makeup of what kind of applications you have in your enterprise.
Thanks, Seamus. We actually had a question about what does MPLS stand for? A lot of acronyms being used.
Okay. Let me see. Multi-label packet switching, I think. Multi-protocol label switching. I think that's what it is. It's basically a technology that's I'm not going to bother defining it, but it's basically the leading form of private WAN connectivity. That delivers like guaranteed service levels and makes and ensures that your traffic is segmented or segregated from other enterprises' traffic and the public traffic. So it's kind of shorthand for public connection, non-internet WAN connectivity.
Thanks, Seamus, for clarifying that. Another question that came in is cloud adoption and SD-WAN also being driven by line of business?
We didn't ask about drivers from line of business. That's a good question that probably should be posed in follow-ups. It's probably true. It's probably, we did research about a year ago where we asked some questions about shadow IT and specifically around cloud adoption. For those uninitiated, shadow IT is a term that people use for technologies in the enterprise that are adopted by basically lines of business. Sales teams adopting Salesforce without involving IT, or some sort of product team, using Amazon Web Services to develop some develop some sort of service for the customers without involving IT. And so we asked these IT professionals whether they had any cloud, any sort of shadow IT activity in the enterprise, and whether certain types of cloud services were adopted by shadow IT versus IT. And we saw significant activity around the cloud where shadow IT adoption was really high for SaaS and infrastructure as a service. And a lot of IT organizations were being asked to support this cloud technology after it had already been adopted. So basically they were telling us that they're becoming aware of their company consuming something like Amazon Web Services or Salesforce.com only after hearing from end users complaining about performance. So their users call up and say, Salesforce isn't working well for me today, and the IT organization would be completely unaware of the fact that anyone in the enterprise is using Salesforce.com until that moment. And so then they have to figure out a plan for supporting something that's becoming integral to the operation, to the business. So that's clearly evidence, from previous research that shows that cloud adoption is driven by line of business. Now, whether it's driving software-defined WAN is also, I think, by extension, it probably is, given the fact that there's so much line of business adoption being in the cloud, and cloud access is a major driver for software-defined WAN adoption.
Great. Thank you, Seamus. We are at our allocated time, so I'm going to go ahead and conclude today's event. You will receive a follow-up email from EMA tomorrow that will include the on-demand playback. I thank all of you for taking time out of your schedule to join us today, and I hope that you're able to join us for a future event. Enjoy the rest of your day.